We're going to actually discuss part 3 this evening of effective aggregate design. I think some of you have been at the previous 2. For those of you who haven't been, I'll recap just a little bit about what we covered in parts 1 and 2. So part 1 kind of established a problem, a situation that a fictitious company was having with modeling their domain. They were trying to apply aggregates in their design, but kind of led to some problems with, say, memory overhead, some transaction conflicts, concurrency conflicts, and so forth. And it turns out that as we analyzed their design, we came up with several different ways to improve their design. And part 2 was presenting some new modeling opportunities that the team came up with. Part of the new design that they came up with was to make smaller aggregates, design smaller aggregates. So instead of having a large cluster of entities and value objects under one root, we looked into ways to take that larger aggregate and break it up into smaller ones. And then we looked at the various rules of aggregate and why adhering to the rules, kind of like staying between the lines, is a good thing when applying DDD. And one of the rules of thumb is protect true business rules or invariants. And so we're going to look at one aspect of that tonight with a new design. We're going to kind of go on a further journey into breaking up aggregates even further and see how that turns out. See if it's actually in our favor to do that. I'll apologize now for the slide formatting. It looks like we got a little, I ended up having to present on a different computer than I expected to, so it looks like some of the formatting is off a little bit. But what is the cost of a given aggregate design? If we start breaking up every single aggregate that we have into just one entity, perhaps, is that really in our favor, or should we think in terms of possibly clustering at least some number of entities in a limited amount under a root? Maybe even go further and compose some value objects under that. What is the true cost of preserving the current backlog item design that we had in the latter part of part 1, and or the latter half of part 1 and part 2, versus breaking the backlog item aggregate up even further into more separate aggregates? So if we can think in terms of, are we staying on board with aggregate rules of thumb, or are we going overboard? Are we trying too hard to model the domain so thin that maybe we cause other problems for ourselves? So where do we strike a balance? And then how can we gain insight through discovery? So as we go into the process of redesigning the current backlog item into maybe another kind of aggregate structure, breaking those up, what could we learn from the discovery process of doing that? We might actually gain more than we ever anticipated. And then finally, it'll be time to make some decisions. What will the team run with? Which model will they go with finally? So a good question is then, is this a small aggregate? As you notice here, we do have a backlog item aggregate root. It holds a number of task entities, 0 to many. And we'll take a look this evening at potentially how many tasks will a backlog item hold under this composition. Further, the task entity each one of them can hold a number of estimation log entries, which in this case are modeled as value objects. There could be some trade-offs in using entities versus values. And then, of course, we have some value objects here, which are just the identities. And we talked about another rule of thumb, which is reference external aggregates by identity only was one of the rules. It's not one that we can never break, but there are advantages to that, and we discussed that in primarily, I believe, in part 2. So question is, then, what do you think? Is this a small aggregate? It kind of depends about this, doesn't it? These two relationships here. Could there potentially be thousands of these under each backlog item? Could there be thousands of estimation log entries too? Well, let's look into it. So how do we figure the cost of this aggregate? There's actually an attribute here that maybe didn't catch our eye right away. We were focused on these relationships here, the zero to many between backlog item and task and estimation log entries. But what about this one here? This is just a string property right now, string attribute. It's the attribute that holds the story description for the backlog item. Now, what we haven't talked about too much is that it actually can hold both a story, I should say a story or a use case description. So right away, what comes to mind? You think of an agile kind of story approach, and maybe you have a few hundred bytes of text in your story, right? Would you have a story that's maybe 200 bytes sometimes? I don't know, or characters, I should say. Or what if we're talking about a use case? What if we have a use case template that allows us to specify maybe many alternate flows besides the main flow? What about exception cases and so forth? Well, actually, under those conditions, a use case could be quite large. So when we load this aggregate now, we may actually have very few tasks and estimation log entries in some cases. But what if our use case definition is costing us way more than we ever anticipated? So one of the team members on this fictitious team that's designing the Agile project management context here came up with this observation. They said, you know what? What would we do if backlog item held maybe 20, 30K of use case definition in some cases? That could be pretty expensive, right? What should we do about that? So, in examining the cost, what might we do to break this up? Is this a true business rule? Does a backlog item require this relationship to a task because of a true business rule, a real invariant? That's the question. Well, let's look a little further. So, when a task has its hours remaining set to 0, so as a teammate, now a team member, a volunteer who's actually using this product, right? We're not talking about the team that's designing this tool or this application, but we're talking about a team member who's actually using this product. For the backlog item that they are concentrated on and the specific task that they've worked on today, when that task is completed, they can go in and mark that task with hours of 0. When that happens, that has a further effect. It can cause the status of the backlog item to transition from committed to done. Now, it actually only happens under one specific condition. This doesn't happen whenever a task has its remaining hours, or any given task has its remaining hours set to 0. It actually happens when the last task with any remaining hours whatsoever has its hours set to 0. So assuming that we have many tasks here under a backlog item, at least 2 or more, let's say, the first task that gets transitioned from some hours to 0 hours does not cause the status here to transition to done. But the last task that has remaining hours, when those hours remaining are set to 0, will cause the backlog item status to transition to done. Okay? So this is why, then, that we have an aggregate boundary around this entire structure here, or cluster of objects. Because what we are saying is, by the rule of aggregate, we are protecting this business rule here. It is a real business rule. And we say that everything that happens within this cluster must commit in a single transaction. Again, that kind of is takes us back to part 1 of this and discussion that we had in part 2. All right? So we are protecting a real business rule here. What would happen, though, if we decided to break this one aggregate apart and divide the backlog item? Now it's a very thin aggregate, and then each task is now its own aggregate, and all that it holds is any number of estimation log entries. And what if we then were to use eventual consistency, or to fire an event that when the remaining hours on this task transition to 0, that we send an event that eventually the backlog item receives some stimulus from that, and then can decide if it should set its status to done. Okay, so that's the question. Should we do that? Think about that just for a moment. What are the consequences? There could be positive consequences. First of all, we definitely have smaller aggregates now, right? So less memory, maybe loads quicker. There's some overhead maybe that we haven't even thought about yet. Besides the memory overhead, there's some additional overhead just in the way that the larger cluster aggregate is designed. But then there are some consequences too for using eventual consistency. So we have to, as always, examine the trade-offs. So have you heard of this book, Programming Pearls? It's kind of an old book now. I think you can find it completely online. I highly recommend going through it. It's got some good old wisdom, let's call it, from software practitioners probably 25 years ago now. But one of the techniques that's spoken about by John Bentley in this book, Programming Pearls, is the back of the envelope. Probably most of us have used back of the envelope. Maybe we use it all the time. We don't really think about it. But here's what we're going to do. We're going to use the back of the envelope and do some cost estimation for what does our current aggregate design cost us, the larger cluster, with the backlog item containing tasks, the tasks containing estimation log entries. Now I'm really disappointed because that was supposed to show up on the envelope. But, yeah, you heard that story before. All right, so, actually, no. That's not supposed to show up on the envelope. I tricked myself. All right, so we're going to measure this. Let's say that most sprints that we estimate that most sprints that teams who use this tool are going to work on are that they're going to be maybe 10 to 15 days long. That would mean 2 to 3 weeks, right? 2 to 3 work weeks. It may not be. I mean, how many here work on 4-week sprints? 3-week sprints? 2-week sprints? So, you know, it's kind of a toss-up. A lot less 4-week sprints, more 3 and 2-week sprints. So we have to think about that. The teams that are using this tool, will they work in more 10 or more 15-day sprints? Don't know. Well, let's just choose a number. Let's say 12. Let's say that we're going to have 12-day sprints, not because we really do 12-day sprints, but because maybe there are more 2-week sprints than 3-week sprints. So we're just going to lean toward 2-week sprints, but we'll throw a little fudge factor in there and say that there are some 3-week sprints. So we're going to say that there are 12 days in the kind of sprints that we're going to think about here. And then backlog item complexity. How do we figure on the backlog item complexity? Well, first of all, there is UI. We're not just talking about the domain model here, right? So we have UI, we have some services in the application layer. We have the model itself, we have some infrastructure and database. So let's just say that with each of those, maybe we come up with 3 tasks per layer for each backlog item. So we specify a backlog item and we say, all right, let's say that there are 3 in the UI, 3 components, maybe 2 in the application, maybe 3 in the model, maybe a couple, 2 or 3 in the infrastructure. That gives us about 12 tasks total. So now we did sneak off the envelope there. So what we're going to do, though, is say that the task complexity is about 12 hours each. That just gives us something to work with. It allows us actually to say that a volunteer team member will work on a task 1 hour per day all during the sprint. So we're going to sort of create a worst case scenario for the number of estimation log entries. Every time that a volunteer goes in and marks their task down by 1 hour, it creates a new estimation log entry. So can you see what's happening here? We have a backlog item. We have a number of tasks, and those tasks will hold a number of estimation log entries. Is that pretty clear? Maybe? Okay. So this is what we're talking about. One backlog item, 12 tasks, so each backlog item will have the number of tasks necessary to address the entire slice down through the system, UI all the way to infrastructure. Okay? And then re-estimations each day of a 12-day sprint, we will finish one of those, or 1 hour on each of those tasks, okay? So that means then that by the end, we have kind of a, roughly speaking, a worst case scenario for this size of sprint. It could change a little bit. We could say, well, Scrum experts say that when the number of hours on any given task exceeds, 6 or 8 or something like that, break that up, make it a smaller task. Well, that would tend to make more tasks, but then less estimation log entries. So, it's just a trade-off. What do we actually want to test for? But this gives us something to work with. So is this really... Sorry. Is this really what we're looking at then? Is it 12 tasks by 12 estimation log entries plus the backlog item? Are we loading 145 items into memory, or domain objects into memory, every single time that we do anything at all on this backlog item? Well, not necessarily. It depends on our fetching strategy, right? If we're using lazy loading, then that doesn't have to be the case. In fact, let's say that both the backlog item and the tasks, or I'm sorry, the tasks and the estimation log entries are lazy loaded. So we load the one backlog item up, and we get ready to do something with a task, like just estimate, change the hours estimated for one of the tasks. We're going to say that it's 12, and we're going to mark that task down to now there are 11 hours left on the task. That's going to cause us to create an estimation log entry. But what happens with the lazy loading? This is what actually happens, right? What we're actually going to have is 25 objects, because we're going to have the one, we're going to have the one backlog item. We're going to have, as soon as we touch, try to access a task, we're going to lazy load that task. And then at any given time, we could have up to 12 estimation log entries. Now, we won't tend to exceed that, because estimation log entries are replaced on a daily basis. Or I should say, estimation log entries only occur on a daily basis. If a developer goes in or volunteer goes in and says, well, I have to re-estimate this again, it's just going to replace the estimation log entry that was already there for that day. So we're still going to constrain this down to about 12 estimation log entries per task. Again, because that's the number of days, and that's the way that we're working this scenario. Yeah, right. Yeah, so it starts out really small, right? So the first day we actually just have the backlog item, the 12 tasks, and then we're going to add one, right? The next day we only read that one estimation log entry back in, so we actually only have one. We add another one. So it stays small, and it really only gets up to 25 on the last day of the sprint. So it's actually not too bad, really, when you think about it from that approach. But, pardon me, we still need to test this out, because, yeah, we may have 12 less tasks. If we break this up, we will have one less lazy load, but we also can weaken the invariant, right? So there's going to be a time lapse between the time that a task has its hours marked down until the backlog item can catch up with it and change its status to done if necessary. Again, thinking about this, when will the status be transitioned to done on the backlog item? In this test scenario, we kind of touched on it a little bit, but is it day 3? Just kind of ask a silly question. Well, it's day 12, right? So it's always day 12 in this test where the status on the backlog item will finally be transitioned to done. So you can sort of see this happening. You're working along, and so many different volunteers are working on this, and the number of estimation log entries are building up day to day. And yeah, eventually there will be 144 collected objects under the backlog item, 145 total with the backlog item, but that only happens progressively. And as it turns out, we actually don't necessarily ever have to have all of those objects in memory. Now, you may think that we do, and we could, but we'll talk about that a little bit more later. But if we were to use eventual consistency, what do we gain by that? We have, again, 12 less tasks under the backlog item. The backlog item will not ever lazy load tasks anymore. In fact, one task will be loaded on demand when that specific task is needed in order to re-estimate its hours or do anything with it. And but we will still have up to 12 estimation log entries under each task. So let's look at the task behavior here. What actually happens when we do transition a task to, well, actually to any level, even if the task says that there are 12 hours remaining, and we reduce that by 1 hour, now there are 11 hours remaining, we're still going to go through this process. So a task gets loaded, the client calls estimate hours remaining. In this case we have 0, so let's just take this scenario where 0 hours are estimated. We add a new estimation log entry, we create this, we actually add it into the collection on the task, and then we create this new task hours remaining estimated event. So this is the event that will eventually reach the backlog item, okay? Or not necessarily reach the backlog item, but cause behavior on the backlog item to get executed. So once the task has completed re-estimating itself, it's going to then create this event and publish the event on a domain event publisher. All right? Also in part 2, I did discuss that this is a lightweight publisher. And this is one thing that kind of gets confused a little bit in discussions about domain events that get published out of the model. All right? In this case, we're just talking about like a gang of 4 observer pattern. It's just very lightweight. The event is actually published on the same thread of execution that this entire use case is executing it. All right, this request, and so the receiver, the subscriber or handler of that event, will also receive it in the same thread. It's what happens after that that's interesting. From that point on, it goes asynchronous, and we can take that discussion offline because it's a little lengthy. But the idea is that we actually want to completely avoid two-phase commit if we can, because it's expensive. So we don't want to publish an event on a queue. I mean, that's just part of the reason, actually. We don't want to publish an event on the queue that may be in a different storage mechanism or have a different persistent storage mechanism for the queue itself than we have for the persistence for the domain model. All right? Ben, you're looking a little, no?
You talk about things like a JPA interceptor or something?
Yeah, very simply what happens is, so the guy that handles this publish event actually just appends or inserts the event into an events table in the same data source as the model is stored in. That way, you have a single, simple transaction. It's very fast, you're just appending. But then, out of band of that, you have another guy kind of spinning, reading for new events placed in that table. And that can then put it on the queue. So, yeah, it's just overhead. I mean, you can do it. You can certainly do it. It's just, what does it cost? What's that going to actually cost in the execution of the model itself? So, yeah, you can certainly do it, and it works. All right. So this is the event that gets published then. This is kind of the details of it. And as you can see, we don't have any chunky objects in here. These are just value objects, IDs, and like just a simple integer with the hours remaining. So just think of this as a fairly lightweight object that's getting persisted and then sent over some kind of a queue or whatever. All right, so now let's jump forward in time, and somehow or another that event got encapsulated by a message on a messaging middleware system, put onto some kind of a queue or bus or whatever, a channel. Now this event gets received as a message from someplace else, and as that message is received, the actual domain event inside it that we looked at in the previous slide is unpacked and used to execute some business logic, right? Everybody kind of have that in their mind. We did walk through this in part 2 in quite a bit of detail, but just to kind of recap, that's what's happening here. Question is, interesting question for you. Is this event handler, is that actually the object that is the subscriber to the messaging middleware thingy, the channel? Do you think that's what it is? Or has that component delegated to something? And there's a really, really good clue here that says, you know, what I would say is that everything inside this if statement could be executed by, let's say, an application service. And you wouldn't be really potentially hurting yourself because of the any business logic leaking out, because all that's really happening is we're just coordinating a task. We're just going to a repository and we're asking for the number of hours remaining on all tasks within the backlog item identified by that backlog item ID. We also are going to another repository and getting a backlog item. And then we're simply delegating to the backlog item to estimate task hours remaining with the total number of hours. So I could see all of this happening as task coordination within an application service. But there is one curious bit about this code example that tells me that it actually probably shouldn't be in an application service. It should probably be in a domain service. Any ideas? This if expression, that's business logic, right? If we put that in an application service, we've potentially lost an important bit of domain logic out of the model, and we now have that in an application service. So what we're saying is, by this if expression, I'm not even going to do this unless my task hours remaining are 0. Why is that leaking business logic? Because, yeah? No, okay. It's leaking business logic because we're saying that we're acknowledging that task hours must be 0 for any of this to have to take place. That's business logic. That's really important. In fact, we could get by with taking this if expression out, right? And we could just say that every single time that we receive this this event, this domain event, hate to have to go back, but this domain event here, every time that we receive this event, we're just going to do this. So take the if out and just execute it every time. But we are optimizing a little bit, and we're saying, you know what, it's completely useless. We needn't burden the database at all to go out and figure out how many task hours are remaining here. So we're optimizing. And this optimization is really only, it contains business logic. We're saying that if task hours are 0, there is the potential for the backlog item status to transition to done. But if task hours are anything greater than 0, then that won't happen, actually.
So task hours remaining is what comes over the event.
Exactly.
Event state.
Right. In fact, I purposely changed the name of this variable because it's not the same name that was used in the event. So actually, whatever this object is that was delegated to from the event handler has passed this thing in, and the receiver of this method invocation has received this as a parameter named task hours remaining rather than just hours remaining. I mean, it's just a little nuance, but I purposely did that just to show that the consequences of handling this kind of domain logic in an event handler. Just something to think about. I would say, in my opinion, is that if this if statement were placed in the event handler itself or in an application service, that you're leaking business logic into the event handler or the application service, wherever it is. But if this is a domain service instead, not, right?
What's the difference then between an application service and a domain service in this case?
Right. So an application service should be used as for things like transaction management, security. It's an application concern. Task coordination. Think of an application service as being like a use case task manager. And it would still use, like, I think it would still have the ubiquitous language used in the names of the objects and methods, like the application service wouldn't be called something or another application service. It would be called backlog item application service. And the method that would be used to invoke on that would also have the ubiquitous language, capture the ubiquitous language. So yeah, they're kind of more thought of as task coordinators, where they're doing things like this. They're going out to repositories and grabbing things and setting up the execution environment, so to speak, for delegation to the model. So we want the model to have the business logic in it. All right?
Isn't it appropriate for a domain service to also call out to the repository?
They can, yeah. Yeah. You could have the application service go to the repository and just pass the objects to the domain service. That may be a matter of taste, but I don't. Do you, Paul, have a problem with? Yeah. I mean, a repository is sort of mostly, I guess, part of the model. Maybe not exactly, but.
I think the repository is like a domain service.
Yeah.
It's essentially in memory collection of whatever.
Yeah. And I think Dan Haywood likes to call a repository an anti-corruption layer around the database, which is kind of an interesting way of looking at it, right? So, all right. So does everybody kind of get that? Then ultimately, this domain event is being delivered, right, asynchronously back into the application just so we can do this. And then inside here is where the status may transition to done. So let's just look at this task repository, because most of the times we just think of a repository as being used to collect aggregates, to fetch aggregates, or to get them, to read them from persistent store. But we're thinking about the task repository as a collection. And so sometimes we might think, well, we don't really want any kind of business logic tucked away down in the repository implementation. But for performance reasons, it can be a good idea to do so sometimes. So what we're actually going to do here is optimize. We're going to have the database. This is HQL. This is Hibernate. And we're just going to have the database calculate the remaining hours. What we're going to do is select all the tasks that belong to that backlog item by identity. And then we're just going to ask it in the database, sum all of the hours remaining. And then we'll return those hours up. So actually, we don't even have to read the tasks, bring them over from the database, right? We just ask for the sum of those hours that are remaining. So that's kind of a slick optimization that we can use to do things, do some business logic if it would cost us either memory overhead or some kind of other performance overhead that's completely unnecessary. Okay, so we kind of know then our strategy for how the model would work and how we would get eventual consistency through a domain event that comes around and eventually affects the backlog item status. But what happens to the UI? In an eventually consistent environment, do you think that the UI can kind of become possibly problematic? Yeah, sure, because, here's an idea of a UI. Maybe we have this collection of backlog item tasks loaded up here in a grid control. And notice that the hours remaining are 0 for all the tasks. So it's Paul is really working hard. That's pretty good. He's got 0 hours remaining on his task. That's cool. Sue has 1 hour remaining. So this tells us we're on the last day of the sprint. We're on that 12th day, and Sue has an hour remaining. She's going to load up or bring up this dialog box of some kind, and she's going to estimate her hours down from 1 to 0. Now notice that currently the status is committed. Technically speaking, when she clicks OK and task hours are now 0 across the board for this backlog item, this should go to 0, and it will, because the task itself is updated in the transaction that deals with the task, right? Remember, the task is broken off the backlog item in this case. But it could be some time before this status is changed from committed to done. So, how do we deal with that? Do we just let it go? Say, well, just tell the users. Sometimes you'll notice that the task, the backlog item status changes from committed to done, and sometimes it doesn't. Don't worry about it. Well, you know that you're going to get like a lot of phone calls and emails and posts to forums and whatever. Why does this happen? So, question is, what do we do about that? Do we just say, well, eventually, when the user refreshes the screen, they'll have, maybe by the second refresh, it'll say done. Do we do that? Is that a great strategy? Well, I don't know, probably not. So what do we do about it? I mean, maybe this is telling us we don't really want to use eventual consistency. I mean, okay, we've really cut down the size of the aggregate, but it wasn't that big in the first place. What should we do here? Should we say, well, we're not used to using eventual consistency, so let's just not use it. Let's favor transactional consistency. Or someone else says, hey, I use messaging all the time. This stuff doesn't scare me. Eventual consistency, that's easy to deal with. We'll come up with something. We'll use Comet or Ajax or something to pull the status, and it'll just blip over to done in time. Is that a good approach? Well, maybe. Maybe it is. But maybe not for the team that's dealing with it. So remember in one of the rules of aggregate, we came up with this question actually attributed completely to a discussion I had with Eric on this. Whose job is it? Because I was asking him, okay, how do you sort of break the tie? Do you just flip a coin and say, well, in this case, I want, let's use eventual consistency because we're all comfortable with it, or let's not. But Eric said, ask whose job it is. Is it the job of the volunteer team member to bring the backlog item status to done? Is it the job of the team? Well, I guess so. Why wouldn't it be? Well, what if a product owner had to approve the doneness of, this backlog item? Let's say they have to run a suite of tests. Let's say they have to actually, go and view it in the UI and prove, both through automated testing and user testing, that it really is done. Then it's not the job of the team. So we could leave the status as committed, or in this case, really pending done, right? If the product owner has to approve it, we're almost done, but we're not done until the product owner clicks the approve button and says, yeah, I saw the test suite, ran, looks good, I used it, I used the feature, looks good. So if it's really the product owner's job to do this, then we don't have that big of a problem, actually. We might know that we're pending done, or even if we remain on committed for some time, it's really not going to hurt anything because the product owner may not, it's not like the product owner is sitting there looking for a notification to flash up and they immediately touch something on their UI, or the UI just pops up in front of them, because they're quite likely in a meeting or something, right? So it could be hours before they even see this, and eventual consistency then isn't even an issue. So they could, if it takes 10 seconds for this, messaging infrastructure to deliver a message and the domain event to be delivered, it doesn't really matter to the product owner because they're likely going to see it in plenty of time. So, is it the product owner's job? Do you think we could come up with a really solid answer here? I mean, what's the problem with, say, assuming that, yeah, you know what? This is actually a new way of looking at this feature, and we think that this product should not support a volunteer, the team members bringing a backlog item to done. Oops, right? I mean, you don't want to, as the company putting out this software, enforce that all teams now have to work under this condition where the product owner owns the doneness of this. Some teams might like that, but I think chances are probably pretty good that it is the job of most team members to bring the status to done. And only in some cases will a product owner insist on themselves running a test suite and looking at the UI and whatever and determining themselves, do they think this is done? It may even be just under special conditions. Maybe this was a really, troublesome bug that drove the team crazy for weeks, and they were trying to work it out, and the product owner said, look, I am simply not allowing this thing to go to done one more time until you prove to me that it's really done. So what we've come up with here is actually more insight into the domain. We actually haven't probably solved the initial problem that we set out to solve by asking the question, whose job is it? But what we have done is realized, well, there's a pretty interesting feature or set of features in our software that we didn't even know we should support, right? So now what we're going to do is, let's think about what it would take to support both of these situations, and potentially even this feature in some cases, optionally. Not only optionally for the entire product or project, but optionally for a specific task or backlog item. So interesting, isn't it, what we can come up with by asking, whose job is it? Does everybody understand that? That kind of turns some lights on, doesn't it? It's a pretty interesting way of looking at things. Well, we've been thinking about all this eventual consistency stuff and whether that will solve the problem for us, but this has sort of been a trick problem all along. And sometimes what happens is, when we're modeling, we'll tend to maybe prejudice our modeling preferences towards something that we like. Like, man, I really want to use eventual consistency. I really want to do this domain event stuff. I really want to use lazy loading instead, or I think that, I prefer this. And so maybe the team actually went down the wrong path in the first place. What if instead they just said, well, the problem is actually the fact that the story could be quite large if it's actually holding a use case definition. And in fact, the ubiquitous language hasn't really been respected in this case because we're not saying a thing about a use case. What if we modeled a completely new concept called a use case definition? That would be actually right along the lines of enhancing our model with additional insight, new insight from that we've gone through with this discovery. So one of the team members says, well, why don't we actually just take care of the problem with the overhead of the use case definition itself? Let's break that thing out. We're never going to store a use case definition in the story. In fact, most times, since most of these teams are agile, we found that most of them are using stories. Only some teams use use cases anyway. So most of the time, there may not even be an object there. We could just have a null, for example, for the use case definition. But in the cases where we do use a use case, we know that it exists, it's not null, and we can lazy load that or whatever we need to when the use case definition is actually needed. Because how many times do we actually even need the use case definition? We need the use case definition when we want to edit or somehow view the use case definition. So most of the times, we don't even want that in memory at all. That's, potentially tens of thousands of bytes of memory usage that we don't want around most of the time, because most of the times we're dealing with transitioning tasks and hours remaining, right? That's what we're doing, I would say, most of the time. Sometimes we may be changing the summary or the story points or something like that, but those things probably don't change as much as on a daily basis while we're sprinting, we're re-estimating tasks. That's at least what I would say. So do you think this is a simpler solution? Actually, if we were to go with this, we don't have to worry about eventual consistency at all. In fact, we know that under our test conditions at least, we've proved that we'll only have up to 25 objects in memory for each backlog item if we leave that cluster together like we currently have it, instead of breaking the backlog item and task apart into separate aggregates. So it sure seems like a good solution. So if you had a couple of radio buttons there, which would you choose? In the essay, I said that the team said, well, let's go with the use case definition model. It's simpler. We can, it's a lot less, there's a lot less risk to implementing that. If we go with eventual consistency, it may not even be worth it. We may just be causing ourselves pain or delaying a feature rollout or something like that, just because we didn't trust our instincts that we understood the model and that 25 objects is probably a good idea as to what it's actually going to be. But let's say that they were way off in their estimates. Let's say they were off by half. Is loading 50 objects into memory to take care of task re-estimation a big deal? Probably not. I mean, even 50 objects are not that bad. So the team could probably have a pretty fair level of confidence that this is going to work out pretty well for them the way that they have it modeled. They'll go with the use case definition, lazy loading that or something, so that it's only loaded when it's absolutely needed. And what they'll do is they can kind of leave the splitting the tasks from backlog item as an option if they find that in, say, beta test, or hopefully not, that it wouldn't go all the way to production, but potentially it could get there and just, bite them. If it did bite them, then they could always come back and address this later. But they're going to go for a safer approach right now. So they'll split the backlog, the tasks from backlog item only with empirical data. They have to have it proven to them that it is a problem, right? They're not going to optimize further unless they know that they absolutely have to. So that's pretty much part 3 of the essay. And I don't know if you wanted to ask some questions or recap. I have just a few more slides if everybody's happy with that. Did that make sense to everyone? Does anything seem like confusing or unreasonable or?
The empirical proof is the key story here. How do you collect this information? Typically, it is production. The true. It always comes down to it. I mean, I guess, not I guess, but you could load up a server and just, use a load testing tool and try it out, right? Log your fetches through Hibernate, log your method execution time on tasks. You could try both, see if it even really makes a difference. I mean, I think you probably would see a difference, right? If you're only loading one task instead of 12 tasks, and you're doing that just absolutely when you need that specific task, it's going to be faster. In fact, if you did that, you might even choose not to lazy load the estimation logs in that case, because probably the potential is pretty high that you're going to want the estimation logs almost every time. Because again, almost all the times when you're touching a task, you're re-estimating, right? So probably you just go for an eager fetch on that And now you have 13 objects in memory. That's pretty fast. I mean, it's got to be faster than the other way. But is it necessary? And the complexity of supporting eventual consistency, that delay, what potential complexities it's going to cause for your UI. I'm not saying not to do it. Like, of course, we use eventual consistency when there's a payoff, and we know that it's necessary. And a lot of times we will get the information, users start calling, man, this thing is slow. This is whatever. Okay, this is going right up on the top of our backlog, product backlog, right? We got to do something about it. So anyway, for now, we're gonna guess that probably 25 objects in memory is not a bad thing. Ben?
Another factor could be, if you took a requirement of just requirements as possible, I could imagine that you need an asynchronous event anyway.
That you need what?
An asynchronous event to say that there might be lots of things that might happen at that point, right? So if you have
Yep.
to have it anyway, you have all the work to do it, at that point maybe
Yeah, and what we haven't looked at in this particular, in this third section of the essay, is that we were using events in other parts of the model. So, yeah, it could be just easy now. We could say, well, what are we wasting our time even discussing this for? We have enough experience with dealing with the inconsistency of the UI. We know ways to handle that. We'll take them to a completed screen and have them click something that takes them back to the other screen, and chances are good that by then, it's updated. I don't know. Things like that. Not the refresh thing. That's probably bad. But I'm not going to claim to be a UI guy here. But Udi Dahan is, he's got his ways of solving that problem, and a lot of people are quite happy with that way. He's got actually, I think sometimes he'll store a date and time, or a time on the UI that tells the user this data was fresh at this point in time. That's kind of an interesting approach, isn't it? I mean, we could say, the user could say, well, I know that I'm dealing with potentially stale data. The time on the screen is informing me of that right now. Or some users go, that doesn't do me any good. What are you giving me that for? It's really up to what the users react well to, right? What do they think is workable for them? So sometimes there's not a real clear answer of the approach to take, but what we have done is discovered some really important domain knowledge. We've made some discoveries that were really core to the business. I mean, they could make some companies really happy by giving them the opportunity to optionally allow the product owner to approve or determine the doneness of a backlog item. That's valuable insight. All right. So what I did want to do tonight, and I promised, is I wanted to announce my book officially. So I did have a little corner of the end of the essay in my bio with one sentence that said, I'm working on this book. And a lot of people didn't even notice it. And, that's okay. But actually, I do want to say that the book is nearing completion. The title of the book is Implementing Domain-Driven Design. And I'm really happy to announce that my publisher is Addison Wesley, same publisher as Eric's book, and also Jimmy Nielsen's book. And man, the formatting. Addison Wesley, this was supposed to look good. My apologies, but I'm going to say that I think that Addison Wesley is a DDD publisher. They want to publish this book because they understand not necessarily DDD from an implementer standpoint, but they understand the power of it, and they want people to learn more about it. So I'm going to say that I at least think of Addison Wesley as being a DDD publisher, and probably we could imagine more good things coming from them. In approximately 6 weeks from now, Safari Books Online is going to host the first half of the book. Okay, so I'm working feverishly on edits right now to get the first half, the first 7 chapters out, so Safari Books Online will be hosting that. I'm going to say approximately 6 weeks. You never know, right? It could be a little sooner, it could be a little later. But let's just say at this point it looks like it's fairly safe to say that. Print. Yeah, I guess we didn't have all the fonts on this machine that we needed. Oh well. Well before the end of year, okay? And I'm just not going to go any further than that. I'm really tempted to giving more of a hint. I'll just say well before the end of the year the book will be in print. And that's what I'm willing to say right now. My whole goal in the approach in writing the book in the first place is to lower the complexity of implementing DDD, right? So a lot of, if you do look at the DDD Yahoo group, many of the same questions are asked over and over and over again. It becomes actually kind of tedious after time trying to help, even though you want to help. So, a lot of what folks stumble on is just getting fired up with DDD in the first place. So I have the first chapter of the book is dedicated to getting started with DDD. It's really helping even the business users to at least somewhat better understand what DDD is, but even more than that, helping the developers understand how to bring the business domain experts into the fold. So that's one important aspect. Then strategic design is covered, I would say, fairly extensively, although I'm in no way claiming to be a strategic design expert in the sense that Eric is. Eric knows strategic design like, nobody else probably. And but I think what I have been able to do is simplify the understanding of that for a lot of people. Hopefully I have done that. Also, there's a chapter on architecture, and I actually go into and demonstrate how to use DDD in 6 different architectural styles, at least, at a high level, if not a medium level at some point. And then I go into tactical design, which has about 8 chapters covering mainly 8 DDD patterns that are used for tactical modeling. And then I implement, I integrate 3 bounded contexts, right, using 3 separate models, 3 sample models. So there is the strategic design, kind of the thought process of it, and the high-level modeling, and then there's the actual implementation of it, or the realization of strategic design in that chapter. And then finally, I address something that a lot of questions are asked about the rest of the application. Okay, so we understand the model, but how do we use the model with the UI? And the question you had, Leo, about what is an application service? How do we deal with that? And then the infrastructure. So I have the chapter on architecture and the architectural styles, but then give me some more detail about the rest of the application. And let's say if we're using one of those architectural styles, maybe even hexagonal architecture, how would I go about, supporting DDD through the rest of the application. So that's pretty much it, and I hope that you all are as eager as I am to have the book fully completed, but at least I'm getting close to halfway there for rough cut online. So again, acknowledgments. This essay was kind of inspired by the DDD Summit 2011, which I was privileged to attend along with Paul and others. And again, thanks to Eric and Paul for the good reviews that they did, and a lot of good guidance from Eric on the essay, and great ideas that he provided. Thank you very much. So that's it.